So this video is going to look at two exam questions on number patterns. Here we have pattern 1 and it's a series of matchsticks 3. And then in pattern 2 we have 7 matchsticks. And then in pattern 3 we have 11 matchsticks. So we recognize a pattern here and we continue on the sequence. So from this pattern we realize that it's increasing by 4 each time. So for part B, part 1, we're told how many matchsticks are required to make the 10th pattern of the sequence. So we're basically going to keep our sequence going until we come to the 10th term. So we go from T6 to T10. So from this then we can see that when we continue on the pattern until we come to T10, we actually come out with 39 matchsticks in that pattern. And now we're going to look at using our TN formula in part 2. Because in part 2 we're asked to find a formula for Tn for the amount of matchsticks that are required. So we write out our Tn formula from our log tables and we sub in A as 3 and N we don't sub in because we want a Tn formula, and we sub in the difference of 4. So do that there now. So now that we've filled in our formula, we're going to multiply 4 by N and 4 by minus 1 and simplify to make a Tn formula. And there we have it, the Tn formula for the number of matchsticks required to make n of the sequence is 4n minus 1. And we're going to use this now in B part 3. So in part 3 we're told that the pattern K has 147 matchsticks. So we're going to put our Tn formula of 4n minus 1 equal to 147 and solve for n. So you go ahead and do that now. And as you can see, when we solve it algebraically, we get n equal to 37. So now we're on to part C, where it says find the formula for S of n, the total number of matchsticks required to make the first n patterns. So we're going to write out our Sn formula. So now what we do is we fill in our value for A and our value for D, but we don't sub in for N. And when we solve it algebraically, we're left with S of N is equal to 2n squared plus n. So we're going to use this S of N now down here. And we're going to put our S of N equal to 820, and we're going to find N, because we need to find the total number of complete patterns in the sequence. So we're looking for n. So now that I've put it equal to 820, I make a quadratic formula from it, and I now factorise this using guide number. So using guide number, I multiplied 2 by 820 to get 1640, and through trial and error I found that 40 and 41 are factors of 1640, and of course they subtract to give you 1. So my brackets are going to have 40 and 41, but I'm going to need to divide now, factorise now using grouping. So rewrite this and factorise using grouping. So this is where I will factorise by grouping here. So I'll divide it down the middle like we always did, split it in 2, factorise the first half, factorise the second half. Pause the video now when you do that. So after I factorised then, I found that my n is actually 20. So by completing the pattern now, we can see that we're now looking at the triangles. So this is 1 triangle, 3 triangles, 5 triangles, and so on. So complete the rest of this table here now. As you can see from the pattern, it's increasing by 2 triangles every time. So what we can see from this question is we're looking at the seating arrangement in the theatre. We're told that row 1 nearest the stage is 28 seats, and as you go further back, each row contains 1 more seat. So we have to find the number of seats in row 10. And through adding 1 row each time, we're going to discover that row 10 in fact has 37 seats. And if there's 50 seats in the last row, how many rows of seats are there in the theatre? So my first one, my A, is 28, because there's 28 seats in my first row, and my difference is 1. It's increasing by 1 each time. So I'm going to use my Tn formula, and I'm going to solve for an equation for n. So I'm going to look for n in this formula. So you pause the video now and solve the Tn formula. So from this we can see that when we sub in a for 28 and 1 for d, we get 27 plus n is equal to 50. What number plus 27 will give me 50? It's 23. So n is 23. And now we need to find the total number of seats in the cinema. So when we want the total number of something, we need to use our SN formula. Total number of seats means SN formula. I'm going to take my n as 23 and use this down here. So write out the SN formula now and fill it in and solve for S of n. So again, we're going to sub in for n for 23, a we're putting in 28, and d we're putting in 1, and again n for 22, and we're going to come out at the end with 897 seats. So for this next part, we're looking at the fact that we are told that on a particular night 600 people are at the show, and assume that people are only seated in rows close to the stage, and we have to fill the first n rows, and there's some people seated in the next row. We have to find the value of n and the number of people sitting in the next row. So we're actually going to use our SN formula here. Using the formula then, we're going to sub in a 28, our difference is 1, and n we don't know, we're looking for n, but I'm going to put it equal to 600 people because that's what it tells me is the total number of people at the show. So using algebra now, work out the value of n. So when I get to this point, I'm going to multiply across by 2 to cancel out my fraction. And what's going to happen is I'm going to cancel these here, and then I'm going to multiply across by n. So here we break it down, and because I'm multiplying across everything by 2, I need to also multiply my 600 by 2, and that gives me my 1200 here. And when I solve this, I'm going to get n equal to 16. And again, subbing in my value for n here, I'm going to come out with s of 16 is equal to 568. So that means the sum of 16 numbers is equal to 658. I know that there's 600 people at the show, so the number of people in the next row is 32, and my n is 16 because I can't have 0.7 of a person. So for part E, we're just asked to calculate the price based on the amount of adults and the amount of children attending and how much each ticket was. So you're going to just multiply 276 by 25 and 212 by 12, and then you're going to add those two answers. So go ahead and do that now. So in this part, they're asking for the ratio of adult tickets to children's tickets, and they're looking for us to find how many adult tickets and how many children's tickets were sold. Looking at this then, we take our ratio of 3 is to 1, we add them and we get 4. So I'm now going to divide my 752 by 4. It's going to give me 188, and I know that that's the children's tickets. So I'm going to multiply 188 by 3 because it was 3 times as many adults, and the adults tickets are 564. So the number of children's tickets, again, 188, and adults are 564. And for the last part then, we're told that the show referred to in part 1, an adult ticket is 2.5 times as much as a child's ticket, and the income was 17,578. Find the cost of the children's ticket for this show. So we are basically making a algebraic expression with an x. So I don't know how much a child's ticket was. I just know that an adult's was 2.5 times that. So my child's ticket is called x. So 188, because I had 188 tickets, multiplied by x. And I'm going to add that to 564 adult tickets multiplied by 2 times 2.5 times x. And I know that those totals equal 17,578. So go ahead now and solve that algebraically. So when we solve that algebraically, we're left with 188x stays the same. We multiply these two, we get 1410x. Put it equal to the total amount of income. Again, add these two together because they're like terms. Divide by 1598 both sides, and I'm left with €11 is the price of a child's ticket.